Hello and welcome back to a new video. In this video, we're going to be covering structs and Go. Let's get right into it. Up to this point in the series, the only way that we could represent higher order concepts is by using maps. But maps have quite a lot of limitations when we're wanting to represent these kind of things. If I want to represent a person, I can make a variable called p1 and make it a map that has string keys and string values. And right there is a limitation. Only string keys and only string values. But let's continue with the solution. So I can have a name property kind of associated with this map and would be equal to my name. But as soon as we get to age, which age shouldn't have to be a string, it should be more of like a uint or an integer represented in our program, but since we're tied down to the limitations of the map, we must make it a string. So that is the first limitation of using maps to represent objects in our program. The next one is that if we have multiple people that we're wanting to represent, so for instance I would have p2 here, I could just not have the age property or age key value pair in this map. But now these two variables right here are hard to compare, and if either one can just hold any amount of key value pairs, then it's not really a concrete solution to representing one particular concept in our program. So instead, we should use structs in Go. So to create a struct to represent a person in this program, we'll do it below the main function in the file. To define a struct, you begin with the type keyword, then the name of the struct that you want, and then the struct keyword. And here is where you get to define the properties or what makes up the struct that you are creating. So we're saying every person in this program is going to have a name, and it's going to be of type string, and then every person is also going to have an age, that will be a uint. Notice how this is similar to a map, but we do not need to comma separate these values. So now if I want to go declare a person, we use the var keyword, give the name, and then say it's of person type. Now when you declare a struct, it goes ahead and sets everything to its 0 value that's within the struct. So let's print this out. So format.println, pass in p1, and when we save and run this, it'll print out the struct using curly braces and print out each property within it. So the first property was the name string, so that's an empty string, so nothing was printed. And then the age property, which is just a uint, and the smallest value or the 0 value for age would be 0. Now some conventions for this are that when you declare a type, unlike in Java or C#, it is lowercase, just lower camel case. And when you go to declare properties, lowercase, or if you want private properties, and then uppercase if you are wanting public properties, just like with functions. To initialize an instance of person, we can remove the var keyword, remove the person type declaration, and initialize this just like any other variable. So we use the assignment operator or assignment and instantiation operator, then use the type that we are going to create and use curly braces. So this would create an empty p1 instance, again with the 0 values for name and age. But if we wanted to go ahead and fill in some values, we can do it one of two ways. The first is to pass in arguments in the order that the person struct has their properties ordered. So I can put in Colton, then do a comma and pass in an age and then end it with a comma. So then if I save and run this, we get Colton and 25. But what if you had a really long struct, something that was maybe 5-6 properties long? Then it might be better to define what is getting assigned to what property up in the instantiation. So instead, I can have name and do a colon and do age and have a colon, and we would still get the same instance of person. Now, which one you choose is up to your preference, but personally, I prefer defining the property and then the value that it's going to receive. Because let's say that I wanted to add a bool in here saying completed school, and it would be a bool. Our program still compiles here, and if we go ahead and run it, we would get Colton 25 and false. But when we instantiate the person up here, we didn't have to include completed school. But if I remove the property assignments, we get a compiler error because we did not provide a true or false value at the very end. So if you want to create your programs to be extensible, then make sure you are using the property names being assigned to the value during instantiation. Now I haven't shown how to access the properties of a struct, but it's fairly straightforward, especially if you already have prior programming knowledge. So up here, we have a person with the name of Colton and age 25. So I can just print out the name by using dot notation and passing in the property name. And this is pretty useful because all we need to do is just type in the dot, and usually our LSP will go ahead and autofill some of the values that we can potentially put in here. So we can only do age, completed school, or name. I can't have some other property trying to be put in here. Unlike where a map, where you could pass in any key and potentially get either a 0 value back or the value if that key existed. If I wanted to change a value of an instance of a struct, all I have to do is just use the variable and then give the property that I want to change, use an assignment operator, change it accordingly, and then we'll go ahead and print this out to make sure that it changed. And when I do a go run, I get 35. And like other value types, we can go ahead and compare two different instances of a struct using the equals equals operator. So I do P1 and P2, which have the same values for both. And we can actually remove that and just do P1 equals equals P2 down here. Let's go ahead and run this, and we get that it is true. They are the same, have the same values. And if we change this to a 35, run this one more time, we get false. Lastly, we can create what are called anonymous structs. So if I remove all of this, if I wanted to quickly represent some sort of struct without creating some large type out of it, we could easily make it by doing this. So I could have person be instantiated to a struct, and then we give the definition of the struct here. So name string and age int. And then after this, we give the values. So I could do Colton and age right there. And then we print out the person. As we can see, this all compiles. So again, you give the variable name, say that it's about to be a struct of these certain types, and then pass in the values. So if I go down here and run it, we get Colton and 25 again. You may be wondering, where is this particularly useful? And you'll see that in future videos that it's useful in niche cases like JSON marshalling and unmarshalling and other more advanced concepts. And that's it for the video. If you stuck around this long in the video, then I would appreciate if you liked and subscribed, and I'll see you in the next one.